Okay, yeah, then we can get started. Yeah, we will be learning about Newton's laws of motion specifically, and the solar system. So we will first cover Newton's laws of motion, and then we will look at some famous scientists in that discovery, and we will also look at the Big Bang Theory, the galaxies and the solar system, and some solar and lunar eclipse as well. So let's start with Isaac Newton. So who was Isaac Newton? So Isaac Newton was an English physicist, mathematician, and one of the most influential scientists in history. And he is best known for his laws of motion, his universal gravitation, and his contributions to mathematics, specifically in the field called calculus. And his work transformed science and laid the foundation for modern physics. So he was a very important figure in transforming the past physics to more of a modern and clear set of physics. And that's what he looked like, his portrait. And also, it was supposed that Isaac Newton got the idea of law of universal gravitation while sitting under an apple tree. And he basically saw an apple fall down and started wondering why things fall down towards Earth. And that led to his discovery. It's a fun fact about him. But there was a more modern physicist like Albert Einstein. So Albert Einstein was a German-born physicist who became one of the most famous scientists in history. So he is best known for his theory of relativity, which changed how we understand space-time and gravity. And he also equated E equals mc squared, which basically shows the relationship between energy and mass. And Einstein also made important discoveries about light and atoms. And his contribution helped the development of modern physics in many ways. So Einstein was also a very famous and important figure in the field of science and physics. Okay, so here were some brief introductions, but let's look at what Newton discovered specifically. So Newton discovered what's called the laws of motion. So Newton's laws of motion are three important scientific laws that explain how forces affect the motion of objects. So these laws explain why things, objects move, stop, or change direction. And these laws also show how force, mass, and acceleration are related, and how objects push back when a force is applied. And again, these laws are defined by Isaac Newton. So let's look at this video. It explains the Newton's three laws of motion in a short time. But
I remember getting my first jersey.
The mascot came out and he just started taking pictures with everybody.
The last shot of the game.
30% off merch at experiences you'll never forget with Chase Freedom Unlimited.
Law says that
Here it is.
have you ever noticed that it's harder to
So, yeah, that was a brief introduction to Newton's three laws of motion. But let's review them, look at them in detail. So, Newton's first law is called the law of inertia. So, it states that an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and in the same direction if no external force is applied. So when an object is at rest, when an object is not moving, it'll stay still. It'll not move unless a force pushes or pulls them. So an example might be a book on a table will stay there unless someone moves it. And for objects in motion that is already moving, will continue to move in a straight line at a constant speed unless a force changes their motion. So think about in space, an object, a tossed object, will keep moving forever in the absence of gravity or air resistance. So on Earth, we feel a little different because moving objects eventually stop due to external forces like friction and air resistance. But the nature of objects, as Newton suggests, states that objects at rest will stay at rest, and object in motion will stay in motion. So let's look at some examples here. If you look at the top picture, you can see the book resting on the table. So unless someone pushes the book will stay still, right? It's not going to move. And then the other part, look at the picture on this, on the right. So it's an Earth orbiting around the sun. So think about if the Earth is moving at a constant speed, it's keep on moving. So unless a force acts to stop the motion, the Earth will move at a constant speed. So that is why the law of inertia is defined to be the property of matter by which an object at rest or in motion tends to remain in its state. And it can be a little confusing, but let's look at some more example. So you can see the picture down at the bottom, and these are people on the bus. But if the bus, when it was moving but stops immediately, you tend to lean forward like this. Lean forward. Because you had the inertia before, you had the tendency to move forward even when the bus stopped. That's why you lean forward. You want to go forward. You want it to stay in motion. And these are just a few examples of Newton's first law. But it's important to know just that objects in motion will stay in motion, and object at rest will stay at rest. So that is the concept. Let's move to Newton's second law. His second law is called the law of acceleration. So in this famous law, he makes the equation F equals ma. So force equals mass times acceleration. So it's saying that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. What does that mean? Well, let's see. If you have a large F, if you have a big F, then when m is constant, it'll lead to a larger acceleration. So if there is an object m, if you kick it hard, it goes further. You kick it hard. It leads to a further, larger acceleration. But if you kick it lightly, it'll only go this much. There will be less acceleration. So larger force leads to larger acceleration. Let's look at another example when there is a larger mass instead. So a person is kicking at the same force, but the mass is different. So if there is a big object and a small object, and a person is trying to push them, the part where there is a larger mass will lead to a smaller acceleration because it's harder to move. It has more mass to overcome. So let's look at a picture here. I think the picture shows a better example. So it says F equals ma. So looking at this picture down at the bottom left, you can see the same person pushing two different masses. One of 500 kilograms and one object of 50 kilograms. Which of these will accelerate faster, do you think? Is it one or two? Oh, yes, that is right. Two will have bigger acceleration. Yeah, nice job. Because m is smaller. Mass is smaller, you need larger acceleration of the same force. Okay, let's look at this picture on the right. So the mass is the same, right? But the force is different. So let's do this again. So it requires this much force by the man for the first one, and more force at the bottom. So which of these have more acceleration? One or two? Yeah, I heard two, and that is right. More force leads to more acceleration. Because if you push it harder, it'll go faster, right? Yeah, that's basically Newton's second law. It relates force with mass and acceleration. Yeah, great job. And now let's look at Newton's third law of motion. It's called an action and reaction. So this law states that for every action, there is an equal and opposite reaction. And an important thing to note is that forces always occur in pairs. So without an action, there is no reaction. So when you push on something, it pushes back with the same force. And everything in motion has a reactive force, even if we don't see it. So an example the video gave was a ball bouncing. A ball hits the ground, and the ground pushes the ball back up. Similar thing occurs when firing a gun. The action is the bullet is pushed forward out of the gun. The reaction is that the gun recoils backwards. So the explosion that actually occurs disperses its forces, let's say, its momentum, as action and reaction that we can observe. So the explosion pushes the bullet forward, but then it also pushes the gun backwards. Okay, so here are some more examples of action and reaction in Newton's third law. You can see the person on a skateboard pushing the ground. So when a person pushes the ground, that's the action. The reaction is the ground pushing to you. It's weird to think about the ground pushing to you, but Newton states that in every action, there's also the opposite in the same reaction. So that's why it makes sense that the ground pushes you. That's why you are able to move forward when you're applying a force backwards. And the boat has a similar example. You push back on the boat, but then you move forward. When you're pushing against the wall, you're pushing against the wall is the action, but the wall pushes you back as a reaction force. Yeah, so this was Newton's third law and how it works. So let's put some of these to test. So let's answer this question. Hunter experiences a backward force upon firing a gun. Which of Newton's laws of motion is demonstrated in this situation?
End of motion. C. C.
Oh, yes, nice job. It's C, that's correct. So you can see in the picture that the bullet pushing forward is the action. Gun recoiling back is the reaction. And this action-reaction is Newton's third law, right? Newton's third law states that in every action there is a reaction. So yeah, great job. Let's look at the next question. A book is at rest on a table. A net force acting on the book could be described as one that
D. 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 D.
I think I heard D, but this is actually not D, because it does not really obey Newton's second law. Well, Newton's second law, remember, is F equals ma. But the object right now is not moving, and it is not being considered for acceleration. So the answer is actually A. So the book is balanced. And that means it's just that the action of the book pushing down on the table is equal to the reaction of the table pushing up on the book. So that's another way of saying that the net force acting on the book is zero, and zero just means that it is balanced.
Hundred.
Okay, so this is Newton's third law in action. So the action and the reactions are equal in magnitude and opposite in direction. Now let's look at pressure. It's a little different concept, but pressure tells us how much force is applied on a certain area. So we can calculate the pressure by force over area. And the unit of pressure is Pascal, PA. And it can be also measured in different units. So there are units like PSI, which is pounds per square inch. There's also a unit called millimeters of mercury, or mmHg, this symbol. And don't be surprised, because that is just another way of expressing pressure in different units. So again, P equals F divided by A. P is pressure, F is force, A is acceleration. I mean, A is area, sorry about that, in this case. So, in the picture on the right, it shows that a more pressure is applied as there is a smaller area, like a tip at the cone. If there's less pressure, when there is a higher area, like a cylinder touching at its base, it has a higher base area compared to the tip of the cone. So, in this question, it says if a cuboid of weight 100 Newton has sides 5 centimeter by 10 centimeter, I've already put out some of the calculation, but you can try to solve it too. So it says to calculate the area and the pressure. And remember, area, how do we calculate the area of a side of a cuboid? It's just the side lengths multiplied, right? So it is 5 times 10 equals 50. Yeah, that's the area. And then pressure, remember, P equals force over area. It says it has a weight of 100 Newton. That means there is a force applied to the ground at 100 Newton. So it is 100 over 50. And what is this? This is 2, right? Equals 2. And Newton, you can put it in Newton per square centimeter or Pascal. You can also name it Pascal, like that. Okay. Does this make sense for everyone? Um, okay, so I hope you are able to maybe calculate some questions like these. But let's look at this question. Can you answer the first part? So explain why a kitchen knife is sharpened in order to cut a piece of yam easily? Why do you think that? A hint is that it has to do with pressure. So think about in terms of pressure. So what happens when a knife is sharpened? What do you think? The area, right, decreases, right? The area decreases. And what happens when area decreases, from E equals F over A? What happens to pressure when A is decreased, do you think? So the question basically wants you to say that when a knife is sharpened, the A area decreases and the pressure increases. It goes up. So there is a higher pressure, right, by sharpening the knife. So here it says, a sharper blade reduces the area of contact, which increases pressure on the yam. So that's why the sharpened knife can cut a piece of yam more easily because it has less area of contact. It can apply more pressure. Yeah, I hope this makes sense. But now let's look at this next question. So, a force of 10 Newton is exerted on a piece of yam using a knife of cross-sectional area of 1 times 10 to the power negative 3. This is the same as saying 0.001 meter. Can you find the pressure of this? Determine the pressure exerted. 제가 뜨는 것 같은데.
나올지.
0.01. 잠깐 일단은 기다려보고 그래도 안 되면 적을 거야.
Questa è una fumetta. Sono bene, sono
시끄럽다. 내가 할게. 알았어. 이렇게. 이렇게.
This times
Yes, so I think you might be able to get to this point. This actually, you can think about this as 10 times 1000 because dividing by 0.001 is the same as multiplying by 1000. So this equals now 10,000, right? And then this is in Pascal units. This is how you find the pressure. So you first identify the force, 10 Newton. Okay. Then you look at the area. Okay, this is the area. And then you divide the force by area, and you can get the pressure. Yeah, does this make sense for everyone? So do you think maybe if you encounter this question, do you think you can solve it?
yes.
Okay, great. So now that it's clear, we can, yeah, this is how you solve it. And let's move on. Okay, any questions about Newton's laws of motion or pressure so far? Do you have any questions so far?
Can you give us one more question?
Sorry, can you repeat the question, please? Um,
I need to ask one more question to solve. One more question to solve.
oh, maybe you want one more question?
Yes.
Yeah.
Question going. 그래. So I think I looked at the question set, but regarding Newton's laws, this is all the BECE had, but I can reserve a couple of sessions, like maybe next week we can talk more about I can find more problems about BEC physics and we can solve together. But I think that was all I was able to find at the moment. But I think there are more questions in this next chapter. So if you don't have any content question, I think we can move on. So yeah, I will try to find more questions for you by next week. So we can solve more questions next week. Okay. So, but now we're moving on to astronomy and the solar system. Okay, so an important figure in astronomy was his name was Galileo Galilei, and he was an Italian scientist, physicist, and astronomer who is often called the father of modern science. He improved the telescope and used it to observe the moon, Jupiter's moon, and the stars. And he discovered that Jupiter has 4 large moons, and he proved that not everything revolves around the Earth. And he supported the idea that of Copernicus's theory that Earth moves around the sun. It's not that the sun moves around the Earth. He proved that the Earth moves around the sun. But before Galileo, most or most of the people believed that the Earth was at the center of the universe. But he proved it wrong in some sort of many different ways. So that was some introduction to Galileo. But let's look at another theory. This was not proposed by Galileo, but it was rather a theory that has been reoccurring. It's called the Big Bang Theory. So the Big Bang Theory explains how the universe began. So the leading scientific explanation for how the universe began and how it has evolved over time. So the theory states that the universe started around 13.8 billion years ago from an extremely hot, dense, and tiny point called the singularity. Then it began to expand rapidly. So they defined the Big Bang Theory as having an initial expansion, then it cooled, then it formed simple atoms, then it formed stars and galaxies, then it formed the modern universe. So let's look at a video, and this shows how the Big Bang Theory occurred and how the universe began. So this will give a brief idea about what it is.
Need to create more video content but don't have enough hours in the day? With Animoto, you can
The Big Bang Theory for kids. Have you ever looked up at a clear night? However, dark energy still remains a mystery because it cannot be detected or measured by the scientific tools we have today. Sounds like a great opportunity to create something new. See that asteroid up ahead? Let's take a break over there and review.
So, yeah, we looked at this video explaining the Big Bang Theory. And yeah, they said that it is a theory which states that the universe started at a tiny point and then expanded rapidly after a big explosion. So, but yeah, it said it formed a lot of stars and galaxies. So, what is a galaxy actually? So a galaxy can contain millions to trillions of stars, gas, dust, and dark matter, all held together by gravity. So astronomers estimate that the observable universe contains around 100 to around 200 billion galaxies. Some galaxies are small, only containing a few million stars, while there are also enormous ones that hold trillions of stars. And galaxies can have different shapes, like a spiral one, or a elliptical one, or maybe even a spiral, irregular one, curly ones. But all of these galaxies just shows a collection of stars, gas, and dust all together. So this is what the galaxies in the universe look like. And this picture at the bottom right is actually our own galaxy called the Milky Way. So yeah, our galaxy is called the Milky Way, and it is a large spiral-shaped galaxy with hundreds of billions of stars. Fun fact, it is around 100,000 light years wide, and our solar system is actually not the center. We are over here. So yeah, we are here in the Milky Way galaxy. That's where our solar system is. And it says we live on a spiral arm called the Orion arm. It's called the Orion arm. And the solar system moves around the center of the galaxy. And one trip takes around 230 million years. So if you're thinking about what a light year is, a light year is a distance that light travels in 1 year. So light is extremely fast. So for 1 year for light, it is around 9.46 trillion kilometers. So it just shows how large galaxies can be. Okay. But now we're reducing the scale a little bit. We're not focusing on the galaxy, but now we're focusing just on our solar system. So the solar system is the collection of the sun and everything that orbits around it. And our solar system formed about 4.6 billion years ago. So the main parts of the solar system are the sun, the 8 planets, the moons, the dwarf planets, asteroids and meteorites, and comets. So here you can see all the components of the solar system. This picture shows a better order. So remember, the sun is always at the center of the solar system. The sun is the center. The closest is a planet called Mercury. And then the next closest is Venus. And then we have Earth where we live. And there is Mars after Earth. And then Jupiter, Saturn, Uranus, and Neptune. So let's look at this video, and it shows this introduction to the solar system. So let's look at this quick video.
DJ Furby, your BFF with the best beats, and you're the DJ. Batteries not included.
The new Infinity QX80 and QX60 Sport are.
So yeah, here is the video. Okay, yeah, that was the video explaining the solar system. So we saw, again, the order in which the solar system is aligned and some properties of each planet as well. So, if you have this order down, I think we are ready to move on. But it is just important to know some of the names of the planets and their order in terms of closeness to the sun. And our Earth is the third planet from the sun. Okay. And you might be wondering, what is a black hole? Because a black hole is a lot of mystery in the field of astronomy as well, but it is a place in space with a very, very strong gravity. And its gravity is so strong that nothing can escape it, not even light. So when a big star dies, it becomes very small and very heavy. And this creates an extremely strong gravity. So anything that gets too close gets pulled in and nothing can come out. So black hole is invisible because light cannot escape it, right? But scientists can find black holes by watching how nearby stars and gases move. So our galaxy, the Milky Way, has a black hole at the center, and it is called the Sagittarius A, and it is very big, about 4 million times heavier than the sun. But let's look at this person explaining what a black hole is, and it's a short video. So yeah, here is the video.
What is a black hole? Well, the name is actually a little misleading because black holes aren't actually holes. They're regions in space that have a gravitational pull that is so strong that nothing can escape, not even light. Scientists know about two different sizes of black holes: stellar mass black holes and supermassive black holes. A stellar mass black hole is born when a massive star dies. That's a star that's larger than our own sun. These stars burn up all the nuclear fuel in their cores, and this causes them to collapse under their own gravity. This collapse causes an explosion that we call a supernova. The entire mass of the star is collapsing down into a tiny point, and the area of the black hole is just a few kilometers across. Supermassive black holes can have a mass of millions to tens of billions of stars. Scientists believe that every galaxy in the universe contains a supermassive black hole. That's up to 1 trillion galaxies in the universe. But we don't know how these supermassive black holes form, and this is an area of active research. What we do know is that supermassive black holes are playing a really important part in the formation and evolution of galaxies, and into our understanding of our place in the universe.
So yeah, I hope from the video as well that you were able to get a sense of what a black hole is. So yeah. Okay, but moving on to some questions from the BECE exam. Which of the following planets is at the center of the solar system?
Mass. Mass.
So it's at the center. So you're looking at the center of the solar system. It's not a planet actually. It's a star, really.
So
Yes, that's right. At the center of the solar system, there's the sun, right? But sun is actually not a planet, but it's actually a star. So planets orbit the star. But sun is at the center of our solar system. Okay. Yeah, the sun is the star, and a star produces its own light and heat, and a planet orbits the star. So the planet does not produce its own light. Okay. Now let's move on to the next question. Which of the following planets are closer to the sun than the Earth? Oh, yes, that's right. The answer is B, Venus and Mercury, because you can see these two planets that are closer to the sun than the Earth. It's Venus and Mercury that are closer. And the one that is further include Mars, Jupiter, Saturn, Uranus, and Neptune. Okay. Um, and by the way, did all of you memorize the order in the solar system? Or so can everyone maybe say it out loud with me? So it is the sun, right? Sun at the center, Mercury next, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So it is important to know this order of the planets closest to the sun. Yeah. Mars, Venus, Earth, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. You can include Pluto or you can exclude it. It doesn't matter, but okay. And I will share you this picture later as well, so you can look at it and you can memorize it. Okay, but I think now we will move on to this next question. Okay, so the brightest of all the planets is, what do you think? I heard B, that is correct. Um, it is Venus, D, that's right. So the Venus is the brightest planet in the night sky, and it's often called the morning star or evening star. And Venus is closest to Earth, and its thick clouds reflect a lot of sunlight. That's why we can see this bright planet from our Earth. Okay. Let's answer this question. The grouping together of many stars is known as what?
D.
Yes, that is right. Heard D, a galaxy, that's right. So galaxy is a group of stars, dust, and gases. But the rest are different. So comet is a small ice, dust, and rock that orbits the sun. astronomy is the study of stars, so it's not a collection of stars. Solar system is the collection of sun and everything that orbits around it. So don't get confused by the solar system and the galaxy. They're different. Solar system is just the planets that orbit around the sun, but the galaxy is a massive group of stars. Yeah, great job. And yeah, I think we actually covered this, so we can move on. Since we already looked at some similar questions. But I will maybe wait for you to read the question and the answers. So yeah, I think the only different question here is the third one. Explain briefly the term Milky Way, and you can just say that the Milky Way is the name of the galaxy that we live in. Oh. And it's called the Milky Way because it looks like a milky band of light. Okay, I think we can move on to this next question. Okay, so it says to state 2 reasons why there is no life on the planet Jupiter. Why do you think that might be? Yeah, I think I heard a few reasons. Yeah, like I think you have said has no solid surface is a gas, right? It's a gas planet. And Jupiter also is really cold. It's extremely cold because it's further away from the sun, right? And like you said, Jupiter has no oxygen for life to breathe, nor water. It doesn't have oxygen or water. So that's why no life on the planet Jupiter can live. Okay. And the second part, list 2 other outer planets without life. Yes, Saturn is one.
And Neptune.
Yeah, right. It's you can say any of these. So Saturn, Uranus, and Neptune. All of these are outer planets that don't have life because it is too cold and it is made out of gas. Okay. So I will move on. Okay. So do you know this question? So people who travel in space are called what? I heard D, and that's right. They're the astronomers, right? So think about astronomist. Astronomist is scientists who study space, but a person who travels in space is actually, yes, that's right. It's B. Yeah, the answer is B, the astronauts. Because astronauts, Yeah, is a person who travel and works in space. It's not a geologist because a geologist is a scientist who studies the Earth. At astronomist, it's not astronomist because astronomists are scientists who studies the space on Earth. But a person who travels and works in space actually are called the astronauts. Okay. 问他大众吗? But now let's move on to the final topic for today. It's called the eclipse. So what is an eclipse? An eclipse happens when one object in space blocks the light from another object. So there are two different kinds of eclipses. There's the solar eclipse and the lunar eclipse. So solar eclipse happens when the moon is in the middle. So the moon passes between the sun and the earth. And the moon creates a shadow on the earth. And it completely or partially blocks the sun's light. So that is the solar eclipse, when the moon blocks the sun's light. Lunar eclipse is when the earth is in the middle. So there is the sun, earth, and the moon. A lunar eclipse happens, when the earth passes between the sun and the moon. And the earth is directly in the middle, and this creates its shadow onto the moon. But let's look at solar eclipses first. So this is what a solar eclipse looks like. You look at the picture on the right top. Okay. So there can be a partial eclipse like this, an annual eclipse, and a total eclipse. So this is the moon actually blocking the sun. So the moon passes directly in between the sun and the earth, and that creates a total eclipse. So you can see the moon blocking the sun completely. Okay. That looks really amazing, right? This is a very amazing natural phenomenon that happens. But there's also the lunar eclipse. This is the other type of eclipse. When Earth comes between the sun and the moon, it's not the moon that is in between, it's the Earth for lunar eclipse. And during lunar eclipse, Earth's shadow falls onto the moon, and the Earth blocks that light, and the moon looks darker or red in this spot. It looks like this on the right during lunar eclipse. Okay, so we covered two eclipses. Now let's quickly answer this question. So, a lunar eclipse may occur when what do you think? I think I heard C, that is correct if you said C. Would you know why? Because here, lunar eclipse occurs when Earth is between the sun and the moon. You can see this is the lunar eclipse when the Earth is in between. So lunar eclipse blocks the sunlight that reaches the moon, and it creates Earth's shadow on the moon. Okay, that is the lunar eclipse. Let's answer this one of the last questions for today. So it says to explain briefly why an eclipse occurs. So can anyone answer this question? Why does an eclipse occur? 수 있을 것 같아.
Happen when one object is light for other objects. Eclipse happens when one cause eclipse happens when one object in phase blocks the lighter from another object.
Yes, that is right. It's when, yeah, like you said, when an object blocks another object. So in this case, we're talking about the moon and the earth, right? So an eclipse occurs when the sun, moon, and earth line up, and one of them blocks the sun's light. Yeah. Okay, great job. And can you name the two types of eclipse? Yes, that's right. Like you said, they are the solar and the lunar eclipse. Solar eclipse and lunar eclipse. Okay. So, oh, we have one more question. This is more of a information. So, artificial satellites can be used for which of these three? Or both or all? Local.
A. A.
Well, you said A, which is one only, but the answer actually is D. It's all of these. So I didn't actually cover this topic, but the main uses of artificial satellites is for communication. That's right, you said communication. One is correct, but it's not only one. It can be used for these ones as well. So it can be used for communication, weather forecasting, navigation and GPS, Earth observation, and many scientific research. So you can look at the oil and gas exploration. That is about the Earth observation. It can also observe meteorological studies, which is for scientific research. So it can also So the satellite is sent up and it sends a lot of signals back to Earth. And again, the main uses are for communication, weather forecasting, navigation and GPS, Earth observation, and scientific research. Those are what it is used for, the artificial satellites. Okay. So that was the end for today's lesson. So do you have any questions for me today?
Yeah.
Okay, yeah. Go ahead.
Segment of GPS. What's the meaning of GPS?
Oh, what is GPS?
Yes.
So
Yes.
GPS actually notes our current location. So GPS tracks where we are. So it is used for many online apps. So when you maybe get a chance to look at a phone, and on the phone there is an app, there's like a map app, right? If you click on the map app, it shows where you are. It says like you are here, and then it shows the map around you. So it tells you your current location and where you need to go. And your current location is observed by GPS. So it tracks where you are. That's what GPS is. And it tells you where you are and where you need to go, the directions.
What's the full name? The full name for it.
Oh, the full name for it. Okay. I will try to.
Yes, I know your name.
I can show you right now. Yeah, the full name for GPS, it's called Global Positioning System. Global Positioning System. Yeah. Okay. So yeah, it just tells you where you are based on the satellites that are used. Okay. Yeah, any other questions today? Yeah. Do you have more questions for me?
Any other question? Any other question?
해봐야지 정신사납게. 이제 노트 난다 보고 있어. 이게 퀘스천. 아니 그럼 정신 사나워. 치웠어요. 나왔어. 이렇게 할게. 아니 정신 사나워. So I'm just going through the slides. So we learned about Isaac Newton. We learned about Albert Einstein. 와, 진짜 방해된다. We looked at Newton's laws of motion. You know, the first, second, and third law. 아니, question 생각하고 있는데 이러면 어떡해. We learned about pressure today. And when we moved to astronomy, we looked at Galileo. We looked at the Big Bang Theory today. We looked at what galaxies are, our galaxy. We looked at the solar system. We looked at the black hole. We looked at different careers related to space, like astronauts, astronomers, geologists, space shuttlers. And finally we learned about eclipse, solar and lunar eclipse. Okay. So yeah. The question also just 물어볼래?
Please, how many types of galaxies do we have?
So can you repeat the question, please? Yeah.
Types of galaxies.
Types of galaxies.
Sorry, can you say that again? I cannot hear you very well. Yeah.
In fact,
Maybe can you come closer and ask the question?
Please, how many types of galaxies do we have?
Oh, how many types of galaxies? Okay.
Yes.
So let's go back to the galaxy slide. And we looked at a lot of different galaxies. So there are no set categories of galaxies, but in the universe, there are around 100 to 200 billion galaxies. So that's a lot, right? And the types can be, spiral. It can look like a spiral. It can look elliptical. Like it can look and it can be irregular. So let me actually expand this photo. Let's look at this one. So we can see a lot of different kinds and shapes. We can look at this elliptical one. You can look at this spiral one. And you can look at this other shape, like this one right here. So there are a lot of different types of galaxies. So yeah, there are billions and trillions of galaxies in our universe. And yeah, I hope that answered your question. Um, so any other questions for me today? Yeah.
Why is it that the dwarf planets are not part of the solar system?
Sorry, can you repeat that one more time? Yes. Our solar system.
What is it? Why is it that the dwarf planets are not part of the eight planets?
So, are you talking about the planets, of the solar system?
Yes.
Okay, yeah, I can return back to this slide. So, if you're looking at maybe the inner solar planets, most says it includes maybe up until Mars, but here are the names of the planets again. Um, the Mars, the Mercury, Venus, Earth, and Mars, you can consider them as the sort of inner planets of the solar system. But the outer ones include, Saturn, Jupiter, Saturn, Uranus, and Neptune. And these ones are mostly gases and are cold. So here just are the 4 planets inside the inner planets, and you can think of these 4 as the outer planets, if you're wondering that one. But yeah, did that answer your question or? 잘 안 들려. 아니야, 그냥 플랜 솔라 시스템 듣고 플랜이 궁금한 것 같아서. 물어본지도 잘 모르겠어. Yeah, any other questions for me today?
How many planets have rings?
Oh,
Rings.
do you mean how the planet can have rings? You mean?
Yes.
Oh, I think yeah, you're talking about Saturn. So Saturn here is kind of special because Saturn's has rings like these, right? Oops. So Saturn has rings, and Saturn has this ring composed of many dusts and gases together. So, so it has a lot of its ice and other torn moons and planets that are nearby. And what this ring actually is the sort of orbiting like ice and rocks, things like scattered rocks that has been broken up. And that's what basically is orbiting around the Saturn. So it's a lot of ice, rocks, and things like that are orbiting around the Saturn. That's why it looks like it has rings, but it is mostly ice and rocks that are orbiting. Yeah, does that answer your question?
Yes.
Okay. Yeah, that's why it has rings. Yeah, any other questions today? If there are no questions, then do you think we should continue to solve some BECE practice problems with physics, or should we move on to the next topic? Um, um, do you maybe want to?
JB,
Yeah.
yeah. So far there is no other question.
Okay.
Yeah. Why? What is the question? Okay, there is one more question. Let me give it up.
Oh, okay. You wanna
Okay. Is the beneficial impact of black holes the Earth?
Sorry, can you repeat the question again, please?
What is the beneficial impact of black holes the Earth?
Sorry, I cannot still hear correctly. Maybe can you type it or you say it? Yeah.
What is the beneficial impact of black holes to the Earth?
Just yeah, can you maybe type it in chat because maybe the microphone is a little buggy right now. Yeah, but that is okay. Oh, you're thinking about, yeah, black holes and its possible beneficial impacts. Yeah, that's a great question. Um, we've looked at this black hole being a place where it has very, very strong gravity. So we're actually not sure if it has any impact on Earth, and that's mainly because black holes that we've actually know about are millions and millions of light years away. So with that distance, it's likely that they're not really affecting Earth. There is no beneficial impact, and there is no negative impact as well, because it's so far away, right? So the black hole is just a result when a sun collapses, and it has a lot of impact to light and planets nearby, but we are really, really far away from black holes, so they don't have any impact to Earth. But yeah, that's a great question, and I hope I answered your question. Yeah.
There is no other question. So we can discuss what we'll be learning next week. Let me see.
So I think what we'll do next week is to look at some more questions. So I will try to focus on gathering the BECE physics questions, or any science questions in general, and we can solve them together next week. Yeah.
So you are able to bring your questions, get questions, science questions, DECE, so that they need to get some. Then you solve it together. Make it available for me to work. Send it to him if possible. And within the week, make it available for me to send it. Is that okay? Yes. All right. Okay.
Okay. So yeah, we will focus on science questions next week, and starting next year, we will focus in other topics like math, maybe English as well. So yeah, then I'll see everyone next week. Yeah, I'll see everyone next week then. All right. Yeah, bye everyone.
Then see you in next week.
Yes.
Send my greetings to the family.
Okay, yeah, and I'll share you the slides right now.
Okay.
Okay.
All right, thank you.
All right.
Have a wonderful weekend.
Thank you.
Bye-bye.
Bye.